This is Ramakrishna. In this video class we are going to discuss about periodic functions. Here period of functional equations are given, that only. We can discuss detailedly in the trigonometric functions. In that trigonometry I am going to prepare one more video class. In that we can discuss periodic functions if any functions are given. Now here functional equations are given. How to find the period, that only we are going to. We are solving a different model questions based on that functional equations. Now let us start. Here I have given the definition of periodic function. A function is said to be periodic function if there exists a positive real number t such that f of x plus t is equals to f of x for every x belongs to t, where the least positive real number t is called its fundamental period. Here see, for example, y is equals to sin x is there. Y is equals to sin x is there. Here this one, the graph of the curve repeats for every length of 2 pi and 4 pi, 6 pi, like that we can take 2 pi, 4 pi, next 6 pi, like that we can take so many. If it is the periodic function, the period of the function is infinite. Infinite periods are there, but there exists only one fundamental period, the least positive real number. In that interval, the function repeats only. For sin x, if you take that one, the least positive interval 2 pi, the length of the 2 pi interval, the graph of the sin x repeats like that. Here 0 to pi, this is 2 pi. Now from here onwards, for every length of 2 pi interval, the graph of the curve repeats only. And one more thing, if it is the periodic function, every periodic function, for every periodic function, inverse doesn't exist only. Why? Because the graph of the curve repeats only. If I draw the line parallel to x-axis, it turns the graph more than once. So periodic functions, inverse doesn't exist only. Here first one, if f is mapping from R to R is a function satisfying the property f of x plus 4 is equals to f of x plus 2 plus f of x plus 6. Here this is the functional equation is given. Here we have to find the period of this function. How to get that one? Here there is no particular rule, but at last we should get. Sometimes see here, whenever we get solving that equation, whenever we get f of x plus k is equal to minus f of x. F of x plus k is equal to minus f of x. Here we can write period of this function f of x equals to 2 times that k. If you get f of x plus k is equal to f of x, here we can say k is the period of that function. And f of x plus k is equal to, if you get minus f of x, we can write directly 2k. How to get that one? See here, replacing x by x plus k. Here this is the equation f of x plus k, that is equal to minus f of k. Whenever we get that one, replace x by x plus k. Here whatever is there, that one you can do that one. Replacing x by x plus k. Plus k is there. Here I replace x by x plus k. Already one more k is there. That is equal to minus of x plus k. Here f of x plus k, that is 2k, that is equal to, here you can multiply with minus of f of x plus k, that is equal to f of x only. So here we got f of x plus t is equal to f of x. So t is the period of the function. Now here you can see, here also what I am saying, there is no particular method, but here replacing x by x plus 1 or x plus 2, like that, the resulting relation should contain at least one term in the original equation. For example, here you can see by solving here, we can discuss 10 or 12 questions, same model questions, then we can get idea also. Here I am replace x by x plus 2. Now here you can see, replace x by x plus 2, then what we can get? f of x plus 2 plus f of x plus 6, x plus 2 plus 4x, that is equal to f of x plus 4 plus f of x plus 6, sorry, x plus 2 means this is x plus 8. Now this is the resulting equation. Here also some terms are there related to original equation. Here f of x plus 2 is there, here also f of x plus 2 is there. Otherwise here we can do one thing. We can substitute instead of f of x plus 2, we can write that expression, or here what I am doing here, adding these two relations. Here f of x plus f of x plus 4 plus f of x plus 2 plus f of x plus 6, that is equal to, right hand side also I am adding f of x plus 2 plus f of x plus 6 plus f of x plus 4 plus f of x plus 8. Here this side f of x plus 2, this side f of x plus 2 both gets cancelled. F of x plus 6, f of x plus 6 also gets cancelled. F of x plus 4, f of x plus 4. We should get the simplest form. To get that simplest form, what should be replaced in the place of x? That one, by practicing a different model questions only we can get an idea. Here f of x equals to, how much we got, that is equal to f of x plus 8. F of x plus 2 is equal to f of x we got. So the period of the given functional equation, that is 8. Next one more, second one, f of x plus 1 plus f of x plus 3 is equal to 2 is given. Here what I am doing, replace x by x plus 2 I am taking. Here 2 plus 1, 3, we are getting this one term. The resulting relation and original, we should get at least one term should be common also. Now f of x plus 3 plus f of x plus this is 5. 2 plus 3, 5, that is equal to 2. Now in the place of, otherwise we can do one thing, both are equal to 2, so we can equate these two also. F of x plus 1 plus f of x plus 3, that is equal to f of x plus 3 plus f of x plus 5. Otherwise here both the sides, x plus 3, f of x plus 3 also can make subject and equating that 2 also. Now both the sides we can cancel this one. To get x here, f of x, here replace x by x minus 1 you can replace. Then minus 1 plus 1 both gets cancelled. Here you can get f of x1. Replace x by x minus 1 plus 1 is there. That is equal to f of x minus 1 plus 5. Now here we are getting f of x equals to f of 4. Sorry, f of x plus 4. So here f of x plus 3 is equal to f of x we got. So what is the period of this functional equation? That is 4. Next one. Here 2-3 problems are there similar to the same type. We can solve this one also. Now here what I am doing, replace x by x plus 1. Then we can get here f of x plus 2 plus, here we are getting f of x, that is equal to root 2 into f of x plus 1. Now here you can see f of x plus 2. Now here we have to simplify this one. Root 2 into, what is f of x plus 1? That is root 2 into f of x minus f of x minus 1. Now f of x plus 2 plus f of x1, that is equal to 2 into f of x minus root 2 into f of x minus 1. Now f of x plus 2 plus, that is equal to, this one you can transfer that side, that is equal to 2 f of x minus f of x, that is f of x minus root 2 into f of x minus 1. Now here if I replace x by x plus 1, here we can get a root 2 into f of x, then root 2 into f of x we can replace that value. So here replace x by x plus 1, then f of x plus 3, that is equal to f of x plus 1 minus root 2 into f of x. F of x plus 3, that is equal to f of x plus 1 minus of, what about the root 2 into f of x, that is f of x plus 1 plus f of x minus 1. Now here you can see plus f of x plus 1 minus f of x plus 1 both gets cancelled. F of x plus 3, that is equal to, we got minus of f of x minus 1. Now here you can replace x by x plus 1. Replace x by x plus 1. So here we can get f of x plus 4, x plus 1 plus 3 x plus 4, that is equal to minus of f of x. Previous I told you, whenever we get f of x plus k, that is equal to minus f of x, here we can write directly the period of f of x is 2k. Here also f of x plus 4 is equal to minus f of x. The period of f of x is, that is equal to 2 4 8. This is also similar to previous one. Previous x plus 1, x minus 1 are there above. Now here f of x plus 2 and f of x minus 2 are there. Here what I am doing, replace x by, replace x by x plus 2 I am taking. So here we can get f of x plus 4 plus f of x, that is equal to root 2 into f of x plus 2. The same procedure only. F of x plus 4 plus f of x, that is equal to root 2 into, in the place of f of x plus 2 we can write root 2 into f of x minus f of x minus 2. So f of x plus 4 plus f of x, that is equal to 2 into f of x minus root 2 into f of x minus 2. Here f of x plus 4, that one you can transfer this side, plus root 2 into f of x minus 2, that is equal to 2 into f of x minus f of x, that is f of x. Now what I am doing here, replacing x by x plus 2. Then here we can get a root 2 into f of x. In the place of root 2 into f of x, we can replace that value. Replace x by x plus 2. Now f of x plus 6, that is equal to that plus root 2 into f of x, that is equal to f of x plus 2. Here I replace the x by x plus 2 only. Now f of x plus 6 plus, what is the value of root 2 into f of x from the given relation? F of x plus 2 plus f of x minus 2, that is equal to f of x plus 2. So here we can cancel these two, and here what we got, f of x minus 2, that is equal to minus f of x plus 6. Now here you can replace x by x plus 2. Here we are very close to the answer only. If I replace x by x plus 2, f of x equals to minus f of x plus 8. So what is the period of this one? 16. Here we got f of x plus 8 is equal to minus f of x, or f of x equals to minus of f of x plus 8. Here we can write a period is equal to 2 times this one, that is 16. Next, f of x plus 4 plus f of x minus 4, that is equal to f of x. Now here you can see, by observing that only we can get idea. Here replace x by x plus 4. F of x plus 8 plus, here we are getting f of x, that is equal to f of x plus 4. F of x plus 8 plus f of x, that is equal to, in the place of f of x plus 4 we can write, otherwise here we can do one more thing also. Here what is f of x? F of x plus 4 plus f of x minus 4, that is equal to f of x plus 4. So here we can cancel these two. F of x plus 8, that is equal to minus f of x minus 4. Now here we are getting that one. Replace x by x plus 4. Then f of x plus 12, that is equal to minus f of x plus 4 minus 4, that is f of x only. Here also we got the same type. F of x plus k is equal to minus f of x. So here we can write it. Otherwise, if you want, you can do that one. Starting also I told you, replace x by x plus 12. Replace x by x plus 12. Here f of x plus 24, that is equal to minus f of x plus 12. F of x plus 24, that is equal to, here minus we can transfer this side, minus f of x plus 12 we can write f of x only. Here also we will get the same type. Period of the function f of x is 24. Here only we can say, whenever we get f of x plus k is equal to minus f of x, period is equal to 2 times of this one. Next one. Here one more. This is very simple question. F of x plus 10 plus f of x plus 4 is equal to 0. You can transpose anything that side. F of x plus 10 is equal to minus f of x plus 4. If I replace x by x minus 4. Replace x by x minus 4. Here this is f of x plus 6, that is equal to minus of f of x. Minus 4 plus 4 both gets cancelled. So here we are getting f of x plus k is equal to minus f of x. So here period is equal to 12. 2 times that k. That is 12. Next one more. F of x plus 1 by 2 plus f of x minus 1 by 2, that is equal to f of x. Here you can replace x by x plus 1 by 2. Then here we can get x plus 1 by 2 plus 1 by 2, that is x plus 1. Plus here we can get f of x, that is equal to f of x plus 1 by 2. Now we can solve these two. F of x plus 1, in the place of f of x I am writing this one, f of x plus 1 by 2 plus f of x minus 1 by 2, that is equal to f of x plus 1 by 2. Now these two gets cancelled. Now f of x plus 1, this one you can transpose that side, minus f of x minus 1 by 2. To get f of x, here I have to replace x by x plus 1 by 2. F of x plus 1 by 2 plus 1, that is a 3 by 2, minus f of x plus 1 by 2 minus 1 by 2, that is f of x only. Here also we got f of x plus k is equal to minus f of x. So here we can write period is equal to 2 times of this one k, that is 3 by 2. Here 2 gets cancelled. So period of f of x is 3. Next one more. F of 3x plus 2 plus f of 3x plus 29, that is equal to 0. Here I am replacing 3x by, replace 3x by 3x plus 27. Now we can get a 3x plus 29. Then we can simplify also that one. F of, in the place of 3x you can write 3x plus 27 plus 2, 3x plus 29 plus f of, in the place of 3x you can write 3x plus 27 plus 29. F of 3x plus 29 plus, whatever this value, f of 3x plus 56, that is equal to 0. Now f of 3x plus 29, that is equal to minus f of 3x plus 56. Now here what I am doing, replace 3x by, replace 3x by x minus 29. In the place of 3x you can replace x minus 29. In the place of 3x, replacing x minus 29 plus 29 is there, is equals to minus of f of, replace 3x by x minus 29 plus 56 is there. So here these two gets cancelled, we are getting f of x. That is equals to minus f of x plus 27 this two. Here also we got f of x equals to minus f of x plus k. So here period is equals to 2 times of this one, that is 54. Consider the graph of y is equals to f of x is symmetric about the lines x equals to 2 and x equals to 4. Then the period of f of x is equals to. Now what about the symmetric? Here what is the condition? For example, if the graph of the curve is symmetric about x equals to a is there. If the graph of the curve is symmetric about x equals to a. Now here you can see from x equals to a, you can take any point at a distance d units. At a distance of d units, then this one we can say a plus d. And this side also at a distance d units you can find one more point. So here we can say a plus d this one. Here a2 a plus d. Here otherwise you can see one more thing. You can say one more thing. Here at a distance d units you can take any one of the point. This one I am taking a plus d. This is x equals to a. Right side d units distance you can take any one of the point. And the left side also you can take any one of the point d units. This is a minus d. Then both are same only. The corresponding y values. What about the corresponding y values? At x equals to a plus d, this is f of a plus d. Here at x equals to a minus d, f of a minus d. Corresponding y values should be same. X equals symmetric about x equals to a. Right side at a distance d units you can take any one of the point. That is a plus d. The corresponding y value f of a plus d. And the left side also the same distance d units from the left side. Here a minus d we say the corresponding y value. Here y is equals to f of x. F of a minus d. Both are equal only. So here if whatever they give, the curve f y is equals to f of x is symmetrical about x equals to a, then we can write f of a minus d, that is equals to f of a plus d. Why? Because by taking a distance right side and left side, the corresponding y values should be same. Here y is equals to f of x. If I take x equals to a plus d, y is equals to f of a plus d. And if I take x equals to a minus d, y is equals to a minus d. F of a minus d is equals to f of a plus d. This is the particular distance I have taken. Otherwise, f of x belongs to R, you can take anything. F of a minus x, that is equals to f of a plus x also you can write. For particular distance I am taking a d only. Here x belongs to, you can take anything. Right hand side and the left hand side also same type only. F of a minus x, whatever we get, the same type, f of a plus x also we will get the same thing. Now in this question what they mentioned here, y is equals to f of x is symmetric about the lines x equals to 2. If it is symmetric about the line x equals to 2, here we can write, therefore f of 2 minus x, that is equals to f of 2 plus x. And that is symmetric about x equals to 4. So f of 4 minus x, that is equals to f of 4 plus x. F of a minus x equals to f of a plus x. This is a symmetric about the line x equals to 2. So instead of a, you can write it 2 only. Now here what I am doing, replace x by x minus 2 I am taking. Replace x by x minus 2. So here what we can get, 2 minus, in the place of x you can replace x minus 2. That is equals to f of 2 plus x minus 2. Here f of 2 plus 2, 4 minus x we are getting. that is equals to f of x only. Here plus 2 minus 2 both gets cancelled. Now from the second relation, f of 4 minus x is given, that is f of 4 plus x. Both are equal only. That is equals to f of x. Now here you can observe that one, f of x plus t is equals to f of x plus 4 is equals to f of x. So here 4 is the period of the function. If the graph of y is equals to f of x is symmetric about the lines x equals to 1 and x equals to 2. Previously we discussed that one. If the line is if the graph of the curve is symmetric about the line x equals to 1, so here we can write f of 1 minus x is equals to f of 1 plus x. And if it is symmetric about the line x equals to 2, f of x minus 2, that is equals to, a minus x. 2 minus x, that is equal to f of a plus x. 2 plus x. Now this is also related to previous type. Here replace x by x minus 1. Then here we can get f of x only. 1 minus of x by x minus 1. That is equal to f of x plus 1. Here we can get 1 plus 1, 2. 2 minus x. That is equal to f of x plus 1. What about f of 2 minus x? That is f of 2 plus x. That is equal to f of x plus 1. Now here you can see how to get f of x replacing x by x minus 1. Replace x by x minus 1. So here we can get x plus 1, that is equal to f of x. So what is the period of f of x? Here f of x plus t is equal to f of x. We got period of f of x is 1. Next one. Let f be a real valued function such that for all x, f of lambda plus x is equal to f of lambda minus x, and f of 2 lambda plus x is equal to minus f of 2 lambda minus x for some lambda greater than 0. Here some options are given. The period and whatever the nature of the function, is it odd or even? And here we have to find the period of the function also. Options are given, but here I am not mentioning that one. Now we have to find period and at the same time the function f of x, is it even or odd? Both we have to find. Now I am taking this relation f of lambda plus x, that is equal to f of lambda minus x. Now here I am replace x by lambda minus x. Here replace x by lambda minus x. Then what we can get here? Lambda minus x, f of lambda minus x. The place of x you can put a lambda minus x only. So this is f of 2 lambda minus x, that is equal to f of x we are getting. And one more thing also given here. F of 2 lambda minus x, that is equal to minus f of 2 lambda plus x, that is equal to f of x. So that is in the form of f of x plus 2 lambda, that is equal to minus f of x. So here we can say period, that is equal to f of x plus k is equal to minus f of x, then period is equal to 2 times of this one. So 4 lambda, that is the period of this function. Now here we can check what about the function, is it even or odd? Here we got this one. In this relation, I am writing again that one, f of 2 lambda minus x, that is equal to f of x. Now here you can replace x by minus x. So this side we can get f of minus x, that is equal to f of 2 lambda plus x. We can replace x by minus x. We are getting that one. Now here you can see f of minus x, that is equal to f of 2 lambda plus x, what they given, minus f of 2 lambda minus x, and minus, what about the f of 2 lambda minus x, that is f of x only. So here what we got, f of minus x is equal to minus f of x. So the given function is odd and the period of the function is 4 lambda. Thank you.